Hello, my name is Anderson Hall. I am the programming lead of Team 0463. I will be presenting my team's Simulink model for the Simulink Design Award. Our team uses an organizational structure based on areas, because we can color code each area to a specific category, such as drivetrain functions being pastels, separate functions being bright colors, and autonomous commands being black/dark colors. We use this categorization by area and color because it clearly defines each individual function, and it allows us to quickly locate functions and separate them visually. Our Simulink model is organized around our drivetrain. Our drivetrain uses many go-to and from blocks to take data from drivetrain functions and autonomous functions. Our drivetrain functions include a slow mode, which divides the output voltage to the motors by a set value, currently set to 2, which effectively makes the robot drive slower. It also includes a reverse drive direction, which allows us to drive the robot backwards as if the back was the front. It does this by inverting the output voltage to both motors and by changing which joystick controls which side of the robot. The main drivetrain area uses a series of states that either pass or don't pass a value through a switch based on a condition. We also have a switch at the end for our respective autonomous motor values. This switch being placed at the end allows us to take autonomous values without having to worry about the autonomous values being affected by slow mode or a other drive function. At the end of our drivetrain code, all of our drivetrain outputs merge into a single signal line to our motors, so we have a clear value that we can look at whenever debugging and testing the drivetrain. Our autonomous command has the end goal of following the taped line on the field and then stopping once the end condition is met. In this case, the end condition is a limit switch. And as you can see, we have old versions of our autonomous commands left in case we need to revert back to them or if we need to refer back to what we did before. The autonomous command is started by pressing 2 buttons at once, connected by an AND logic gate. This sends a signal to start our state flow and set our auton state to true, which lets the autonomous motor values output to the motor instead of the joystick values. We also have push buttons here in the code, so we can test autonomous while monitoring it from our laptops. Our state flow is a simple loop that drives the robot in a straight line until it hits the IR line, and then it will turn until it is not on the line, and then continue until a limit switch is pressed, which then it will end the state flow.